Alright, so in this video we will going to see about the next algorithm, which is round robin algorithm. And in previous videos we have seen that the first come first serve algorithm, the shortest of first algorithm, right? And the shortest remaining time first algorithm. So basically round robin algorithm, the concept of this algorithm is, suppose there are many processes available, P1, P2, P3. So there is one thing that is used, time quantum, right? So each process is provided a time quantum for the execution of a job, right? Suppose time quantum is 2 units. So this process will execute 2 units of time, right? After that, the if the execution will switch to this, right? So this will execute 2 units, and then this process will execute 2 units, right? Then again follow this, again start from here, right? So it follow a cycle, right? So it gives the participation to all of the available processes, right? So this is the basic concept of this algorithm, and you can see the flow chart of this algorithm. So this is ready state, right? So if the bus time is less than the time quantum, right? So the execute till completion. So suppose time quantum is 2 and the bus time of any process is 1, right? So it will execute completely and then terminate the process. And if it's not, so execute for time quantum, so it will give 2 units of time, then again go for rescheduling, right? All right, so let's see a question, right? So the questions actually are a little bit tough to solve, such not tough, but actually it's a kind of tricky question, so you have to take care of many things here when you are solving these kind of questions. So this is Gantt chart, right? And you have to take a queue here to solve such kind of question. It's a queue, right? So suppose process start from 0. So as 0, the process 1 will be available and process 1 will execute. So you have to maintain the queue here. And the purpose of queue is to keep the available processes, right? So that it will be easy to switch the processes. So at P1, so P1 bus time is 4, so it will execute 2 units of time, right? So P1 will execute 2 units of time, right? So here it will be 2, and then at 2 units of time you will see that the process P2 and P3 will be available, so you just have to write it here, P2 and P3 will be available here, right? So now this time which process will execute? P2, right? So P2 will execute and P1 already has executed, so you just have to write here, right? So P2 will execute 2 units of time, so it will be 3 here, and this will be 4, right? Then P3 will execute. So at 4 unit of time you will see that P1, P2, P3, P4, right? And P5 process will be available. So you can write it here this way, P1, P2, and the P4, the P5, right? So P2 will execute 4 units of time. So P2 will come here now, and then P3 is time for P3. So P3 will execute 2 units of time. So it's going to be 6 here, right? So at 6 unit of time, you will see that the process number P6 will be available, right? So just write it here. And now this time P3 has already executed, right? So P1 will execute P3 and it is complete 0. So when any process is complete, you don't have to write, right? So for rescheduling, or you don't need to keep it in queue because it will take only resources. So P1 will execute 3 minutes of time this time, and this will also going to be complete here. So this is going to be 8 here, and P1 finishes. Sorry. Now P4 will execute. So P4 will execute only 1 unit of time, right? 4, and this is only 1 unit of time, and this is also going to be complete here. Now the remaining processes are P5 and P6. P5, P2 and P6, right? So P5, this time P5 will schedule for execution. So P5 will execute 2 units of time, here it will be 4, there will be P5 and 9 to 11 here. And then again, after the P5, P5 will schedule here, right? And then you'll see the P2, so P2 will execute here, 2 units of time, is going to be 13, and here we're going to be 1. Now P2, you have to write P2 here. So now this time P6 will execute. So P6 is 3 units of time. So P6 here execute 15, and the remaining job going to be 1, right? Then P6. So this P6 executed here. So you just have to write it here. And now the time is for P5. So P5 is 4. So it will execute this time. So P5 will execute 17. It will be 17, right? And P5 will be here now. So this time P2 will execute, and if you look at P2, it's only 1 unit of time, so it will be 18 only, and this process will going to be finish. This time P6 will execute, P6 will also going to be finished because the remaining time is only 1, so this will also going to be finished here. And now the only job that is remaining, so P5, and so P5 is 2 units of time, so it will take 2 units of time and get finishes 21, right? So that's how you have to prepare and keep track of all the, this is actually queue, so here you have to keep track of the processes, right? So which process you have to schedule, right? And this is Gantt chart, right? Gantt chart. Now I'm sorry, we need to calculate the completion time with the help of Gantt chart. So as I've told you that you have to start from there, and if you focus on to this, so you will find that this algorithm is much similar to first first come first serve algorithm, right? First come first serve algorithm, but actually this algorithm was non-preemptive algorithm, non-preemptive algorithm, but this algorithm is preemptive algorithm, right? So you are preempting the one job, and then you are taking the next job, then again you are doing this, so you are providing the quantum time. And one thing also you have to keep in your mind is this algorithm is based on two things: the burst time, I'm sorry, the arrival time, the arrival time plus the quantum time, right? So here we are taking two things in for the execution of job. So now, sorry, this we have to find the completion time. So for P1 the completion time is going to be 8 here, right? Yeah, 8. For P2 the completion time will be 18. For P3, the completion time is going to be 6. For P4, the completion time is going to be 9. For P5, the completion time is going to be 17 and 21. 21, and for P6, the completion time will be 19. And with the help of completion time, you can calculate the turnaround time, right? So just turnaround time, and you have to know that turnaround time is equal to completion time minus arrival time. So completion time minus arrival time, which is 8 minus 8, 0, 17, 4, 6, 17, sorry, and the last one going to be 19, 30, right? So the completion time, so you taking the completion of arrival time minus arrival time. And with the help of turnaround time, you can calculate the waiting time, and waiting time is equal to the turnaround time minus turnaround time minus the bus time, right? So here the bus time is 4 to 4, 15, 12 to 5, 17 minus 6, which will going to give you 11 and 10, right? So that's how you can calculate, and now you simply, and you can look at the calculation like finding the average waiting time. Average waiting time. So average waiting time is going to be 4 plus 12 plus 2 plus 5 plus 11 plus 10 by 6, right? And 16, 21, 21, 21, 20, 26, 20, 28, 28, 38, 40, 44, 44 by 6, 7.3 something, right? 7.33 something. So that's how you can calculate these values. And in question, they might ask you about the completion time of process 3. So you have to simply tell them this is going to be 6, or completion time of process 5, so it's going to be 21. Or sometimes they ask you the turnaround time of process 3, so just have to tell them. Or if they ask you to calculate all the values or like average waiting time, so you need to perform this way: average waiting time or average turnaround time, right? So you need to go this way. Thanks for watching.